I'm Anil Kumar. Welcome to my series on trigonometry. Here in part 2, we'll discuss all formulas which you need to know for your exams, which are related with compound angles. That is to say, things like sine A plus B, cos A plus B, double angle and half angle formulas. I'll not only give you the formulas but also show you how to use them, right? So let's begin with sine A plus B. So most of you remember it is sine A cos B plus cos A sine B, right? And the formula for sine A minus B is very similar with a negative here, right? So it could be written as sine A cos B minus cos A sine B, right? Now this basic formula can be used in many different ways. If I add them up, what do I get? If I add them up, I get sine A plus B plus sine A minus B equal to what? These two terms cancel, so we get twice sine A cos B. We get 2 times sine A cos B. Perfect. Now, from here, we can actually derive many formulas. Let me show you how to get a formula which is very, very important and which is called sum to product formula. I'm going to make a small substitution here. The substitution is, we select A plus B equal to C and A minus B equal to D. In that case, when I add them and divide by 2, what do I get? Well, if I add them, that is to say, let me say these two we are going to add, right? So we get 2A equal to C plus D. So A is equal to C plus D divided by 2. Perfect. This is when I add them, right? So these two formulas, let me show it like this. When I add them, the operation performed is addition. Now, what happens if I subtract them? Now, if I subtract them, then what happens? 2A cancel, we get 2B, right? So we get 2B equal to C minus D, or B as equal to C minus D divided by 2. Do you see that? So we are going to make this substitution, which I have shown you on the right side, to derive another very important formula. See how? We are saying that A plus B is C. So I could write this as sine C and then this as sine D, right? Because D is A minus B. 2 times A is C plus D by 2. And cos of B, which is C minus D by 2. Do you see that? So that is how we can get a formula which relates sum to product. Perfect. Well, I could have subtracted these. So if these two equations working here, if I subtract them, that is to say, if I do minus, in that case, what do I get? In that case, I will actually get sine C plus, we are subtracting, minus sine D, and do this math which we just did, equal to 2 times Now when you subtract, you get twice cos A sine B. Do you see that? Twice cos A sine B. So here you get 2 cos A C plus D by 2, and here you get sine C minus D by 2. So at this stage, since you have worked a lot with these formulas, it is only exam review. This hint helps you how to derive the formula. I hope that makes sense. Perfect. So these are some two product or difference two product formulas which are very important to solve many questions. Correct? We could similarly work with the cosine. So if I have cos of A plus B, we know that is equal to cos A cos B minus sine A sine B, right? And cos of A minus B is cos A cos B plus sine A sine B. Now in this case, if we add and subtract, what happens? So if I do the addition part, in that case I get cos A plus B plus cos A minus B equal to, these two terms cancel, so I get 2 times cos A cos B. And if I make this substitution, which you just saw, correct? In that case, A plus B is C, so I could write this as cos C plus cos D equals to twice cos of C plus D by 2 times cos of C minus D by 2. Now here is a tricky part. What happens when I subtract them? These two formulas. What I'm trying to say here is that I want to now subtract them. Then what happens? In that case, we get cos of A plus B minus cos of A minus B equals to, first two terms cancel. We get the next two terms but with a negative sign. Now this is critical. Sometimes students forget about it. So it is negative sine A sine B, and therefore the formula which you get here is cos C minus cos D equals to negative 2 sine C plus D by 2 times sine C minus D by 2. Do you get the idea? So you see how beautifully we have actually got some of our formulas which are very difficult to derive otherwise. But now you can understand the logic and get them through. Perfect. So that is very important. Now, before leaving this, let me also get back to another concept, and that is what happens when I make B equals to A. So what happens when I make B equals to A in these compound angle formulas? So for sine, if I make B equals to A, what do I get? So I have sine, I'm going to the very first one, A plus A, right? So B equals to A is basically equal to, so we get sine A cos A and cos A sine A, right? So we get 2 sine A cos A, or sine of 2A is equal to 2 sine A cos A. So that's the double angle formula for sine. And if I do the same thing with cosine, then I get what? Cos of 2A will be equal to, look at this cos formula. If I make A equals to B, in that case we get cos A times cos A, which is cos square A, minus sine square A. Perfect. So that is how you get your double angle formula. Now, This formula, which is cos 2a equals to cos square a minus sine square a, is very important to remember. And from here, we get other formulas. So it is the mother of other formulas, right? So combined with the information that sine square a plus cos square a equals to 1, we could actually derive many other formulas from here. So let us see how to do that. Okay, so I'm going to just keep it slightly neater. So we'll now work with cos 2a formula. So we have cos 2a as equal to cos square a minus sine square a. So instead of sine square a, I could write 1 minus cos square a, right? So I can write 1 minus cos square a. Perfect. Now that gives us cos square a minus 1, and this is plus cos square a. So I could write this as 2 cos square a, right? So I get cos 2a equals to 2 cos square a. Correct? Similarly, if I change and write cos square a as 1 minus sine square a, then I'll get what? I could also get, let me write here. So cos 2a could also be written as cos square a as 1 minus sine square a minus sine square a. And that gives me 1 minus 2 sine square a. Perfect. So we get cos 2a as equal to 2 cos square a minus 1 and also 1 minus 2 sine square a. Do you see that part? Now these formulas can be rearranged. So now the important part here is to isolate cos square a and sine square a terms. And if we do that, we get our half angle formulas, which I'll continue in the next sheet. So let me show you here once. So we have cos 2a as 1 minus 2 sine square a. So I could write this as 2 sine square a. 2 sine square a, bringing it to this side, is 1 minus cos 2a. Correct? So that means what is sine a equals to? So first I'll divide this by 2. I get 1 minus cos 2a divided by 2. And then I'll square root it. So when I square root, I make plus minus. Perfect. Similarly, from this formula, I can isolate, right? I can isolate. I can write this as 2 cos square a equals to 1 plus cos 2a, right? And taking it on this side, we can say that cos a is equal to plus minus square root of 1 plus cos 2a divided by 2. Got it? So we have got all the formulas here relating to sine and cosine. I have missed the formulas based on tan, which we'll take up in the next page. And also, we will see how to work with these formulas, which could be related with double angle and half angle. So the double angle formulas are already with you, right? So the double angle formulas are right there. So we have one double angle formula here, which is sine 2a. Then we have cos 2a formula written in the form of cos square a minus sine square a. We also have written the same formula as 2 cos square a minus 1 and as 1 minus 2 cos square sine square a, right? So I hope you understand and appreciate how we have developed sum 2 product and double angle formulas in this particular sheet. Now let's continue and take up the tan formulas and half angle formulas in the next page. So let me again begin with the double angle formulas. First double angle formula we derived was sine 2a equals to 2 times sine A cos A. We got cos 2A as equal to cos square A minus sine square A. This could also be written as cos 2A equal to 2 cos square A minus 1 and cos 2A equal to 1 minus 2 sine square A. Correct? Now in the later half, we also learn that these two can be rearranged. Correct? So when we rearrange them, let's work with the one given here. When we rearrange it, bringing 2 sine square A to the left side, we get 2 sine square A equal to 1 minus cos 2A, or sine square A equal to 1 minus cos 2A divided by 2, or sine A equal to square root of 1 minus cos 2A. Little bit of repetition has been done. Since it is very important, we need to understand the derivation also. Perfect. Okay, now at this stage, I'm going to do a very simple substitution, and let us say that we write 2A equals to theta. In that case, A will be theta by 2. So if I do this derivation, I will write here that sine theta by 2 equal to plus minus square root of 1 minus cos theta over 2. So we get our half angle formula. You could do exactly the same thing with the cosine part of it. Perfect, which I am saying you could actually again start and follow all these steps to get your formula, which is cos theta by 2 will be equal to plus minus square root of 1 plus cos theta by 2, and if I divide one by the other, we get tan theta by 2, right? So tan theta by 2 will be plus minus square root of sine theta by 2, which is 1 minus cos theta, by 2 cancel, 1 plus cos theta. So you get half angle formulas from your double angle formulas straight, as I've shown you just now. Perfect, very easy to remember. Okay, so we didn't talk about tan formula, so let me write down tan A plus B formula, right? So tan A plus B, I'll just give you the formula to remember, is tan A plus tan B over 1 minus tan A tan B. Perfect. Now if I write tan 2A, that means I'm making B equal to A, right? So if I say B equals to A, we get tan 2A. So that gives you 2 tan A divided by 1 minus tan square A. Perfect. Now remembering minus, tan A minus B is simple. If it is minus here, this becomes minus and that becomes plus. Is that clear? So that is how you could actually remember the formulas for tan A plus B and tan A minus B. Correct? So these are all the formulas which are very important for you to remember, and I hope it makes sense, right? Now, once you know these formulas, you can actually derive the formulas for sine 3a, right? Cos 3a, right? So I like you to derive the formula for sine 3a and cos 3a. So sine 3a, you will write sine 2a plus a, expand and get your formula. 3a is equal to 3 sine a minus 4 sine square a, right? You can always derive it, by doing sine 2a plus a, expanding and then simplifying. Now, cos 3a. Now, this could be written in different forms. As you can realize, we can write sine square a as 1 minus cos square a and get it in different forms. Correct? Now, cos 3a will be written as 3. We can write this as 4 cos square a minus 3 cos a. And tan 3a could be written as 3 tan a minus tan cube a divided by 1 minus 3 tan square a. Now, to derive these formulas, the method which you could adopt is something like this. Sine 3a will be equal to sine of 2a plus a. So expand this. So we get sine 2a cos a plus cos 2a sine a. Correct? Now, sine 2a is known to you as 2 sine a cos a. So you could actually write this as 2 sine a cos a times, we already have cos a here, plus cos 2a, you could write as cos square a minus sine square a. Times sine a. So here we get 2 sine a cos square a, and when you open this bracket you get plus cos square a sine a minus you get sine cube a. If I want to write all the terms in sine, then I will replace cos square a as 1 minus sine square a, right? So when you combine these two, you get 3 sine a. Now cos square a could be written as 1 minus sine square a, and we already have minus sine cube a, right? So what we have is, so when you open this up, we have 3 sine a minus 3 sine cube a minus sine cube a, and that gives us 3 sine a minus 3 sine cube a, right? So that is how we derive the formula which I have given you right on the top. Right, so no, I wrote square here, it's cube. So that is how you get your sine 3a formula, and that's the derivation. You could follow similar procedure for cos 3a and tan 3a and get their formulas. I hope that makes sense. Good, I derived this and corrected my result there. Sorry, here also minus 3 and minus 1 is 4, sorry. So minus 3 and minus 1 is 4. So 3 sine a minus 4 sine cube a, right? So that is perfect. Okay. So this is now correct, okay, and this is also correct. Let me rewrite this. 3 sine a minus 4 sine cube a. Okay, so that is the derivation, and I hope with this you understand how to work with compound angles, double angles and half angles, and the simple derivations which I have taken up in between will help you to prove some identities. I hope that makes sense. Feel free to write your comments, share your views, share my videos, and also watch the part 1. We have talked about the basic trigonometric formulas dealing with the angles in a triangle. I hope that makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.